priority. We've got to turn the project in early.
Hey, everybody. I don't know. It looks like we might have 1 or 2 people watching. So if you're watching, I'm going to do a few problems right here. I know some people have been emailing me, so I figured I'd hop on here. If you're in the chat, feel free to say hey. Good old Mario music to start. Got the chocolate chip problem. I don't know how Mario relates to chocolate chip problems, but, you know, never hurts to have a little Mario music in the background. If you're here, say hey. I think the link's been sent out. We'll see if anybody is in the chat. Let's see, we got some 1,000 chip trial. Now, a few people have asked me, does that mean the sample size is 1,000? Well, what they're doing right here, it's like the Chips Ahoy, 1,000 chips in every bag claim. So they're saying that each bag of chocolate chip cookies has 1,000 chocolate chips in the bag. That's like the 1,000 chocolate chip trial. Kind of bad that they maybe use the word trial here because it's not saying we're doing 1,000 trials. It's like the 1,000 chips are on trial. Like we're testing this claim to see if 1,000 chips is true. Now, this could be done with a hypothesis test, which I think I'll also follow up with because we just did hypothesis tests and we talked about how confidence intervals relate to hypothesis tests. So we have here at least 1,000 chocolate chips is what they're looking for. They're looking for at least 1,000 chocolate chips. A bunch of students go out and purchase random bags of chocolate chip cookies and they count all the chocolate chips in each bag. I'm glad we're not doing that. That'd be quite tedious. Some of the data is shown below. Complete all the parts. So you can look at the different bags right here. You got this bag. It passed, but it didn't have nearly enough. I mean, nearly as many as these. Wow, that one almost had 50% more. That's a lot of chocolate chips in a bag. It's like you just gonna have some chocolate chip cookies that are just like all chocolate chips. Some of the stuff we can do right here is we can copy the data to the clipboard or we can copy it to Excel. We're just going to hit Command-C or Command-V, Mac versus PC. We're going to hop over here to Jump. Jump's going to make our lives a lot easier. If you don't have Jump, you can do this in the TI calculator with Stat, and then go to Test, and then T-Test, or T-Interval, excuse me. Stat, Test, T-Interval on the T calculator. You'll need to enter in the data. I do have a video going over this. I think I show how to maybe enter in the data in the video. Please email me if you're stuck, but it can be done with the TI calculator. You can also use online tools or StatCrunch or other things to enter in the data and get the summary statistics. So let's show this with the summary statistics. You should be able to find the mean of this data. You should be able to find the standard deviation. There's a lot of tools online where it's like find the mean, find the standard deviation. So if you don't have software, well, most people have Excel. Let's say you don't. Let's just say for a moment you don't have Jump on your computer. So we're going to go over and we're going to open Excel because I would assume everyone will have Excel. So let's go over to under the assumption you have Excel. Whee! So you have Excel on your computer and you paste in the data. So here's the data. Now we're going to find the mean for the data, which Excel is the average. There it is right there. You double click it and then you select your vector right here. Vector is just a bunch of data. And then we're going to click enter and it's going to calculate the mean for us. We're going to go below here. We're going to do standard deviation. If I can remember which formula it is, I believe it's this one. Estimate standard deviation based on a sample. Good. So it says it's going to do the estimate standard deviation based on a sample. That's what we want. We're going to, not that one. I did not say that one. I said this one. And I hate to say it, I do not know the difference between all those standard deviation formulas in Excel, but these are the ones we're using right here, just so you can see. You can see up here in the corner. I'll show you it once again. There we go. There's that formula. And there's that formula. We'll double check to make sure these work. But we've just calculated the mean and the standard deviation. This is probably going to look pretty good when we do in Excel because we can write on Excel. So we've got our mean, we've got our standard deviation. Let's take some notes on this right here. We've got here the data. We're going to go to the pens. Excel's not doing the normal pen thing like it usually does. Where's my draw? Let me see here. Let me go to tabs. Is Word doing this too? We had this happen one time. Let's see. Word's got draw. Word knows what's up. Why would it do that? I want my draw pens. Not my documents that I don't need. Why would it do that? Well, okay. Let's put a note beside it. This is Y bar. This is S. And then we need to find the standard error. So to make a confidence interval, we're going to need the standard error. The standard error is the sample size. So we could actually get N right here. Let's put a note for N. And N is going to be the count. Does it have some sort of count? It does. Can we use it? So the count right here is this. And that worked. We now have to tell them the count. The count is just how many observations there are. It's the sample size. You can call it count, sample size. Count is how it codes it, and sample size is what it is, and the notation is n. Once again, know your notation. We can't do formulas in here, can we? Oh, we can. So we're going to make this the real y bar. Or not. We can't do the equation thing. Maybe we can. Maybe we can. Oh, looks like we can. I'm very happy when we can write the real y bar. It looks like it's like some overlay box, but you know what? That works. Cool, we got the real y bar in there. That makes me very happy. So we have the sample mean, we have the standard deviation. Now we need the standard error. So the standard error of, and we can even do the cool thing right here. Watch this. We're going to take this. We are going to copy this, and we're going to shrink it down. We got to reduce the font size. And then we're going to put this thing, where are you at? We're going to put it right down here. This is some ultimate notation right here. We got the standard error of y bar now. So now it's very, very clear. Look, we don't need our pens. I'm sorry, Space Pen. But, hey, Brian, yeah, you got it. Of course, Elizabeth, you got it. I'll finish off this one, then I'll go and do the next one. I'm doing all the notation right here, and then I'm going to do it in jump like that. So I'm going to do this one here with this, and then I'm going to do it in jump, and maybe I can do it in 10 seconds an hour. You got it, Elizabeth. Put the question you want in the chat, Elizabeth. You got it. The standard error is simply the original standard deviation. So I'm going to use the Excel way of selecting this cell, and then I'm going to divide it by this cell. Whoops. Be careful, this is not the answer yet. And I want to show you, we have to divide this by the square root. And I don't usually put formulas in Excel. I don't usually, but that's the square root. That's S over the square root of n. You got a psychology one next with the rats. You bet. So this is S over the square root of n, and that has calculated it. And now here's where people are going to get stuck. People will get stuck on this question now. You've got your y bar, you've got your S, you've got your n, you've got your standard error. And the whole thing we're trying to do right now of this question, the whole point of this question, Space Pen's back, is to solve y bar plus or minus t s over square root of n. Now the s over square root of n, which we just found, is the standard error. That is the standard error of y bar. But the only thing we don't have right now is the t. We do not have the t, and I'm sure Excel can probably, maybe I'll write it in Excel. I know people who have had to do these things. I bet I can figure out how to solve it in Excel. Let me see. Let me do an Excel, and I'll show you the applet way. So we want the t statistic, and we need to know the degrees of freedom first. The degrees of freedom are simply going to be this cell minus 1. So we go equals this cell minus 1. There's our, we could have figured that out. The degrees of freedom are 9 because it's n minus 1. You can see here the formula for the degrees of freedom. It's not that. Excel, calm down. And now the t statistic, how do you do it in Excel? T distribution, is that going to do it? Returns the left sailed tide of a t distribution. There's the two-tailed, there's the right tail. So we could do the two-tail, inverse t, I think we want. Returns the left-tailed inverse. Let me think here. Yeah, we want inverse t, and it's the left tail. So if we're doing like a 95% confidence, it'll be this, and then the second arm is the degrees of freedom. So there we go. So this should get me the t, and it's going to be like 2.2, 2.201. I think I've done this problem too many times. But I wouldn't do it this way. There it is right there, and you could just make it positive. But we're going to do plus or minus that t statistic. Now let's show where that t is coming from. I'm just showing how to do every little bit of this problem in Excel, which, I've never really done it all in Excel, so I'm just having fun doing it for myself in Excel. What I would do to find the t is I would go to the following applet, which is now going to be in the chat. Here you go, chat. Here's the applet. And when you go to the applet, what you want to do is you want to say we have 9 degrees of freedom and we're building a 95% confidence interval. There it is right there. You can view it better maybe if you do this, and it'll make more sense. And you don't have to worry about writing the code into Excel because you see it's negative 2.262, and there it is right there. It rounds. And that's so interesting that this one, the way it's rounding it, is not the same as this. So it always makes me wonder when we see small decimal differences. I don't like small decimal differences. But it looks like they're close enough with how they align. And so now we just need to solve the formula that we've written out in Word. So all we do here is plug in numbers. I think it was 2.26. So we have a mean. We got to go grab that mean. Let's go look at the mean. The mean is 1258.1. And the standard deviation, plus or minus a t of 2.26. And it was like 2, something like that. And then we go here, and we get the standard error. So I'm going to do the s over square root of n part of it. The s over square root of n is 114.749 over square root of 10. Now, solving this interval is just the last step. That's all we do. All we do is we solve that interval. But here's why I would do it in JUMP. If you paste your data into JUMP, you go to Analyze Distribution, you double click, you hit OK, and the answer to your 95% confidence interval is right here. There's the answer. And so we've solved it. We've solved the whole interval like this. Now you should understand the relationships that you have right here, the lower of the interval. Yep, you got it, Morgan. Great question, Morgan. We would give you it. We don't want you to find it. We wouldn't be like, what is the t? Well, there are ways to backwork it. Like I can solve for the t here. Watch as I do this. Try to follow along. I'm taking 140.1868. Does everyone see that? Minus 1176.0132, like that. I have now found the entire length of the interval. Does that make sense? I have found the entire length of the interval. Here's half the length. I have just found the what of the interval. I have just found the margin of error. I found half the length of the interval. I found half. This right here is half the length of that interval because I did the upper minus the lower, and I took half of it. So now I have the margin of error of the interval. So watch this. If I take the margin of error and I divide it by this, I'm going to do this in my head. Let me do this in my head. I'm going to divide these two numbers. 2.2612. 2.2621. And so this right here, what I did was by using these formulas is I used the margin of error. I know what the margin of error is. So I kind of did some algebra we might want you to do on the test. That's, like we could ask you, somebody like, well, you never said we'll have to find the t. Well, if we give you the margin of error, and then we go over here and we say you have a t statistic, and then this last thing is a standard error. So if you want to find the t, all you have to do is this. So we've done questions like this, where you can find the t. So I found the margin of error, and then I divided it by the standard error, and that told me the t. I could also find the standard error by dividing, you can do it any which way, but it's algebra now. So some people are like, wait a minute, you never said we don't have to find the t. And it's like, well, it's a algebra. It's understanding the equation. It's understanding that these are the components, and if you know how to identify this, you can find this from this. So I was able to find the t right here, and that's what I found on the calculator of 2.262 by doing, if you can barely see it, this right here was the margin of error. Is there a history? I thought there was a history button on this. There it is. You can see the history of what I did. Let me move over side. Really? Oops. You can't move the calculator when you do the history button. So you can see where I found, here's where I found the length of the interval. Here's where I got half the length of the interval, so that's the margin of error. And then I divided it by the standard error, which gave me the t. So that's how we can do some more complex questions. One thing I do want to point out, though, once again, you guys know I have love of R, and then we're going to do Elizabeth's question next. But just to show why I really love R, if I go here and I just put in my data, not that data, let's go see how quick we can do it in R. Let's get the speed run on the screen. I want to see how quickly we can do this problem in R, had it been given to us in R, which I love data. I love working with data. We're going to copy it to the clipboard. We got it here. Jump might be quicker, technically, because Jump's, you can point-click stuff. Okay, so here we go. Start the clock. We paste the data. Ooh, and I got a trick for this. So we're going to call this data. We're going to store into it. Then the trick I found out from teaching myself random things. Oh, it's not that. It's this. There we go. Now I can put commas after all those, and I click there. So this is our data. And whoops, there's our data. And then we go to t-test, and we put data inside of it, and there's the confidence roll right here. So that was under 30 seconds. So as soon as I had the data, the longest part of that was inputting the data, and then I run the t-test. Now you say, why are you doing a t-test? Well, the t-test can also be used to do a t-interval. It also gives me the t-interval along with the t-test. I can also test values here by saying mu equals to something like 800. So think for a moment on this. This is a good review of yesterday's class. 800 is outside the interval. Will the p-value be high or low for this? 800 is outside the interval, meaning we would reject it. So the p-value is going to be low. So if we look at the p-value here, the p-value is low. Let's take a number like 900 that is inside the interval, and 900 is a number we think might be true, and 900 being inside the interval has a higher p-value. If we go even more towards the center, the p-value will go even higher because it's even more likely. You see the p-value getting higher until you pick something maybe directly at the center of the interval, which was like, what, 1180 or something? And now the p-value is going to be extremely, extremely high because this is very much towards the center. It even gets you the t-statistic for the test. So if you're following along with this, you understand how tests and confidence intervals are created, that this confidence interval are values you think are possible, and i.e. you would not reject them because they are in the interval. So we've got all of our numbers right here. I'm going to take it from here. The numbers, once again, we solved this quite a few different ways. Random, 10%, you know what's happening. Random, 10%, and random means independent. So let me see here. Data is less than 10% of the population. The data from a random sample. Check the data for independence. Okay, wait. The data are a random sample, so one can assume they are independent. Data from random sample. Okay. Such a weird way to word it. 10% doesn't come into play if we're checking that. Show the shape of the distribution. This is, you can do a few things here. You can look at the data, or you can use jump. Jump's going to be your best avenue for this. The bin widths are a little bit different here. We could change them. If you notice the bin widths on this problem, it's snapped to there. The bin widths on these problems go from either 700 to 1400, and actually that gives it away because they're trying to trick you. It's unimodal like this. We have very little data, so it needs to be kind of nearly normal. So it's not this one. This has the wrong starting. It has the wrong shape. It's mainly built up around the middle, and you can see that by the 1200s. You don't need jump. You could, but, and you know what? R just makes life so easy. Because I can go right here and go hist, data, and here, ooh. Oh, no, there's a problem. When I was writing one of my data points, I deleted it. Someone's going to see that in the video. There we go. Good thing I made that histogram, or I would have not seen that my data is not correct. I deleted some numbers as I was writing them in. My jump interval is correct. I was like, that interval is really wide. Usually they complete the 1,000 chip trial. I was like, well, that's so weird. So I misentered a data point because it was user error. User error is a big problem. So it is this shape right here. We have confirmed that by looking at it in jump, or just kind of like process of elimination. Process of elimination on this one. This one starts at the wrong bin because it should start about 900 because that's where the numbers begin. They go up to about 15, 16. So this one wouldn't even include this high value. And then it's also unimodal. So it has to be the unimodal one with the right bins. Done. Evaluate the histogram. It's unimodal symmetric with no outliers, so one can assume the data scale follows the normal. It's not bimodal. It's not asymmetric. It's not bimodal. Cool. Create a 95% confidence interval. Once again, please review earlier on. I did this in Excel. I did every little bit of it, and then I went over to Word and put the numbers into the formula. So pause the video here if you don't have jump or want to do it. Also, you can do it with the t-test on the calculator. There's a lot of ways to do this. As long as you have a good way of doing it that works for you, you're good. So we now go back to the problem here. We grab the numbers. I'm going to grab them from R just because I trust R the most. Don't let me down, R. Okay, you don't want me to let me copy click those? Don't let me down, R. 1 decimal place. Well, I could have rounded the interval anyways. You know what, R, you're gonna super help me out here. I wonder if I can put round on this. Will it work? Oh my gosh, what did I do? It's like ultimate zoom out. It doesn't like that. I won't worry about it. I bet it produced probably a list, and I need to go inside that list. If any of my jump people are watching, I bet it outputs a list. I could save it and then do that. Okay, I'm afraid. I'm always scared of those numbers because we always make a decimal error on it. It's classic. It's classic Mike Pearson to make that decimal error. So what does this evidence support for the claim? Now, here's the biggest thing. It's not talking about individual chocolate chip bags. It's talking about the mean of all bags. It's like, I am 95% confident the true mean of all bags for chocolate chips is contained in the interval blank to blank. So because the entire confidence interval is above this, the mean number of chips per bag is more than likely this. However, the normal model predicts that a small amount of individual bags will have fewer than 1,000 chips. Yeah, you could run this with the normal model here. We can go ahead and do that. Let's go grab our data from Jump. We're just going between all the software. We've got our mean and our standard deviation. You can see that 1,000 chips would be a z-score. Let's go 1,000 is our observed. We have a mean of this. We do observation minus mean divided by standard deviation. For a singular bag of chips, it would be a z-score of about this, which is, like kind of unlikely, but could happen. But for the average to be below this is quite different because the average being below this is super unlikely. We would use the standard error then. We'd have to see how many standard errors it is below. So observation minus mean divided by the standard error of the mean, which standardizes the mean. I want everyone to think about that for a moment. Pause on this and just tell me if we got a few people watching. The standard deviation is used to standardize singular observations. The standard error of the mean is used to standardize what's. Think about use the standard error of the mean for confidence intervals, for the mean. Use the standard error of the mean to do tests. And all I did was take the value of 1,000, subtract off this, and divide by the standard error of the mean, because that's how we standardize differences for the mean. But if I want to check a singular bag, one bag, I take the observation, which is the same, I subtract the mean, which is the same, and then I divide by the standard deviation because that's for a singular observation. What's up, Hunter? Does that make sense for anyone watching that this one is how you standardize means, because it's a standard error for the mean, and this one is how you standardize singular observations. So if something says make a confidence interval for the mean, you'll use the standard error of the mean. If it says test the mean, you'll use the standard error of the mean, which is basically like a standard deviation, but for the mean. It's how we standardize differences for the mean. So it's like here right there. This is the standardizing of the mean right here, how we create standard differences. So very, very important. It's just S over square root of n. So it's related to sample size. And I think we've done it, as long as I don't click a wrong answer. Not today, my Pearson. Not today. That's what we say. Not today. Not today. Okay. Next one. Next question right here. And I'm going to see if I'm doing the replace questions. So make sure we're doing them all. We have the rats in a maze question. Let's do the rats in a maze question right here. The rats in a maze question. Replace questions. There's a lot of questions. The rats in a maze question. Put your question in the chat if you have it. We're doing the rats in a maze question. Here it is with sodium content. Wait, this is the right one, right? Rats in a maze. There's the 1,000-chip trial. Yes, we've done it. We got some rats in a maze right here. Let's do it. Okay. So with these rats in a maze, you put the rat in the maze, it runs through the maze, and then we see how long it takes because we're just experimenting on all the rats. And let's see. We've got our data. Now, what's kind of cool is, let's say, everyone would love it if I posted it. We could literally create a solver for ourselves in Excel. Now, you should learn the formulas and everything. But with what I've previously created from the last problem, and I'll do this in Jump and I'll do this in R real quick too. But with what I've previously created, we probably want to do a little bit of if we paste the data right here, now we just have to do some changes. So we have to find the mean, which is the average. What I'm going to do is I'm going to take this end vector right here. I'm going to put it all the way to 200. As long as I don't have more than 190 data points, I'm good. So that found me the mean. I'm going to go to the standard deviation of the data points. I'm going to put this to 200. Boom, there's the standard deviation. I'm going to click this one. I'm going to get the count. And you'll see the whole point of this is just to get the summary statistics. We did 21 trials, looks like we did. Now we go to the standard error. That one doesn't need to be shifted. That one's good. And then here's the T statistic. And then we have to go, and it's already doing it by the degrees of freedom. So I've kind of created a solver now. I could even have it solve the rest of the equation for me. And there might even be a T, might just even be a T interval. Looks like it doesn't have a T interval in here. It doesn't have it already hard programmed into this. It might be in the statistics analysis tool pack, but I don't know. I haven't done all these things in Excel. But who here is lost on this part? Or I think it was Elizabeth you asked. How far are you along on this one, Elizabeth? Because I'll show you. You could also go into Jump, open a new worksheet in Jump, paste with column names. That's so key. And then go to Analyze Distribution, double-click the variable, and then click OK. And we have our histogram, and we have our confidence interval. Is this all making sense right here? So review that part of the video right there. We've got our histogram, we've got our confidence interval, and everything's been created for us right here. The 95% confidence interval. Do you have Jump? Do you have Jump? Do you have Jump? It looks like there might be an outlier. They might ask us. So do this. You ready? Do you have it pasted into Jump? Here, I'm going to show you how to paste it again. You ready? We're going to go to File, New Data Table. Now, don't click inside of it. I'm just going to full screen it, but don't click inside of it. go to Edit, Paste with Column Names. And then if do you have Jump Hunter? It makes it really easy. I was doing it in Excel a moment ago earlier on, so you can see I did it in Excel to get it. All right, is everyone right here? If you have Jump, are you right here? Have you gotten your data into Jump? Have you gotten your data into Jump? How are we doing on this, everyone? Good, and then go to Analyze, Distribution. Analyze, Distribution. Once you go to Analyze, Distribution, you're going to double-click the variable, and then just click OK, because that's what you want to analyze. Once you've done this, just go up here to Stack, and that just makes it easier to read. You can set defaults, but I keep mine normal because if you're like, why is yours stacked to begin with? Like, I had defaults on my other computer, but then confuses people when my graphics turn different by default. I don't know why they don't stack it to begin with. I don't want to read stuff like this. I want to read it across left, right. Did you get to this part right here, Elizabeth? And how you doing on this, Hunter? How you doing on this part right here? Did everyone get to this part right here? This right here. This gives us our 95% confidence roll. And do this. This question, I think, has a second part. Go here and go to Redo Recalc. Automatic Recalc. That's what we want. Do this right here. No, you're fine, Hunter. Don't worry about it. If you rewind, I was doing it in Excel earlier. So I did it all in Excel. If you go to you'll see me start to fill out the Excel worksheet. Check out that part, and you'll see me write down everything in Excel and show you how to write the formulas in Excel. Because some people don't have Jump. So it's all right if you don't use Jump. It just makes life easier. Like once you know how to do it, you're like, oh, click, 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 click. There's my interval. So once you do this, nothing changes. You're welcome, Hunter. Feel free to ask. Now, if we get through more questions, I'll go back and I'll show. Like it's in the video, so you can see me going through and writing down each thing in Excel. And you can do it on the TI calculator. If you have a TI calculator, it's stat test t interval. On the TI calculator, it's stat test t interval. And I've got the videos for that too. Let me pull up one of those videos. So if someone's watching this right now, let me put that video in the chat. So stat test t interval. Stat 1. UTK YouTube. Tomorrow I'll be caught up on sleep. I passed out. I woke up this morning. I was like, what time is it? And I was like, it's 10 in the morning. It's like, what happened? T interval. Oh, you guys can hear it. It's 5 or something.
A student wants to compute the min
You can see it on.
Q1 median.
You can hear it. It's Brian Inception. T interval. Let me put this list in the video chat. Once again, anything you want to throw a like on in this, if you want to throw a like on one of those videos, you're more than welcome to. I mean, you don't have to. You don't have to watch any of the videos. You don't have to like any of the videos. But all the videos in here are labeled what they are. Like this is the T interval video. And so the T interval video is what you want to use. So you can easily do these in the TI calculator. They don't take long at all. So here's and I try to make it quick. The videos are like 2 minutes. They've got ads because we're trying to get these scholarships for students. We're up to like $36. And once we get that first scholarship for a student, I'll be so pumped. Once we get that first scholarship, like we could do a first $100 scholarship, like congratulations, happy day. So let's finish off this question right here. I think the hardest part of this question is getting these numbers right here, finding these numbers, finding the lower and the upper. And then it's going to ask us, I believe, to remove the outlier. So let's get the question on the screen. So create a 95% confidence interval for the mean time it takes to find the food. Once we've created this 95% confidence interval right here, we are good to go. So we've got our 95% confidence interval created inside of Jump. Here it is. 59.31 is the top. And then the lower is 47.08. And plot the data. Jump really helps with this. We've got an outlier. So if you notice, we need to find the one like this one with the outlier. And it's between A and C. What's the differences? Well, here's what you can do. You can take this. You can go from 20 to 100. And this goes in increments of 5. So if you really want to know, I'm thinking it's this one right here. I was thinking it was this one. But this helps out. If you go to Jump, you're between the two of these because they have an outlier. It's very hard to tell. It's a close call. So, without Jump, that one's a little bit more difficult. Okay, this one gets people all the time. Everyone's like, how in the world am I supposed to know this? Does anyone remember what a QQ plot for normality should generally follow? a QQ plot for normality should look like what? If it's good. And this one is mostly good. This one is kind of like, it's pretty... A line, you're right. And the line goes up and to the right. Now, this is perfect normal. It follows a perfect line. Does this look perfect here? Does this look 100% perfect normal? Like, oh my gosh, that's the best normal curve ever. It's got that outlier. Wait a minute here. It's almost like that's the outlier. That is the observed value up here that was very high, and it's a very large z-score. So this is telling you the z-score on it, and this is the observed value, and you can see here 100, and this does not have an observed 100. You might say, well, this one has an observed 100. It can't follow this pattern behind my head. That's just not a pattern it makes. It doesn't go down. It doesn't go this. It has to be this one right here. And you can process of eliminate because a normal quantile plot will always go up and to the right. Once again, in R, I just like it because it's really easy. Here we go to library reg class. Sometimes they can be plotted a little bit differently. These are the chocolate chip cookies. So here's the chocolate chip cookie trials, and the chocolate chip cookies mainly follow the normal distribution. And so a lot of plots will give you the bands and everything, but it mainly follows the red line, so it's pretty normal. And then if you look at the histogram of it, it's also pretty normal too. And I like it, you can just type QQ and you get the plot. So it's a QQ plot for normality. And if you notice, this is very, very normal. So the nearly normal condition is satisfied for these data. I know it's the chocolate chip, but we got this one outlier for these. That's... Oh, this question. Okay. Are the conditions satisfied? Randomized, random. You knew it was going to happen. So we got random, normal quantile plot is relatively straight with one outlier. Without the outlier, the conditions seem to be met. The histogram is roughly unimoral symmetric with no outliers. Okay, then what's this one say? The randomization condition is met. The normal probability plot is relatively straight with one outlier. Without the outlier, the condition seems to be met. The histogram is roughly bimodal. Nope. This is our best bet so far. This condition is met. It's not straight. Wrong. Okay, that looks to be right. So without the outlier, everything looks to be good. It's kind of an extreme outlier, and it's a smaller data set. So they're going to ask us to remove the outlier if I remember correctly. Yep. Okay, so here's the big thing. Pause. This question's really easy if we do the following. If you do it in Excel, like if you don't have jump, you have to go back here, and I guess it's really easy too. You have to delete this, and will all the things refigure? Yay! So now you can use these numbers here, your mean of this data set, which we programmed in at the very start of this video. We wrote a little thing to get all of our numbers. You get your mean, your standard deviation, your sample size, your standard error, your degrees of freedom, and your t-statistic being calculated for you. Once again, we could get this t-statistic nice and easily by going over here, saying we have 19 degrees of freedom, and that is the same t-statistic you see right there, that 2.093 right there. Same t-statistic being calculated two different ways. This is when you want to solve the formula by hand. When you solve the formula by hand, you have to input the numbers. Nothing wrong with doing that. One way to solve it right there. But the easiest way to do it is just by going into jump and saying, hey, jump, remember how we said earlier we want to go here and go to redo automatic recalc. Make sure that is checked. If it's checked, don't click it again. With automatic recalc clicked, we can highlight the point. We can go up here to the ... It might be at the top of the screen on the Mac. If you're on a Mac, it'll be at your top. You want to go to rows, hide, and exclude. So let me pause on this. Make sure you have that highlighted and go to rows, highlight, and exclude. Now you'll know you've done this properly if your data changes. Watch the data right there, and as soon as I click, the data is going to change. Here we go. There, the data changed. So now it's recalculating. That's what automatic recalc does. So we have our answer. We've done it. 46.868, or what does it want, 2 decimals? 46.68. 46.68. And then the other decimal, 55.39. It's gonna get something wrong, right? Did the maze meet the requirement that it takes at least 1 minute? Is 1 minute in the interval? Nope. So the maze does not meet it. Are both intervals below? I didn't see the other interval. Ooh, that interval is barely below, so it doesn't meet it. Both confidence intervals contain it. Nope, they don't contain it. The maze does not meet the 1 minute average requirement. Both confidence intervals are entirely below. Not today, my Pearson. Not today. That's what we say. Did you get it done, Elizabeth? How'd you do on it? Does it make more sense? Which ones are people stuck on right now? There's a few others I haven't done right now. But since we've been following along, making sure we have the notation, if you're watching this video right now, hopefully you're... Oh, nice job, Elizabeth. Yeah, that's what I want to see. the process for all of these questions is very similar. And that's why hopefully, do you get, like, I want to give people confidence. I want people to be like, okay, I'm getting it. Okay, wait, this, I find the mean, I find the standard deviation, I know my sample size, I can get my t-statistic, I can build my confidence interval. It's all about that notation. If you've been following along, be like, it's all about that notation. Got to know what the notation is, and then you just use the formula to solve, and then you have to know what it means. You have to be like, okay, this is trying to figure out what the true mean time it takes for the rest to run the race. I'll start doing another one here while we're talking. I'll do one of my favorite ones. Yes, I found it. I can get the bottom one. I can't get the top one. This top one is super hard to guess. 2 degrees of freedom for a 99% confidence. That's ridiculous. It's gonna be like 18.12. That is like so hard to guess. The probability of me being around that one is like nothing. This one though, I can kind of get 2.36. Probably get a 50 on this. Yep, got the bottom one. So if you get these, you're super lucky, because what you have to do is you should go to the t-applet right here. You should enter in that there's 2 degrees of freedom and you have a 99% confidence roll, and it was 9.925. So all you do is you go to the t interval, and so it's 9.93. Is that going to be right? And now we got 100. So I was able to guess it, and I'll do this one right here. Oh, wait, that's the same ones. Change the question. Oh, it gives me the same version whenever I do that. If I go away from it. Okay, here we go. I can do the bottom one. Okay, if you're wondering, how can I do these bottom ones? Because I know the answer for the z. And as the degrees of freedom get higher, what happens to the t? It becomes more normal. As the degrees of freedom go up, the t becomes more normal. So as the degrees of freedom go up, the t becomes more normal. So here's what I'm doing in my head. I say the z-score, which I've memorized, is this, and then the t is more smashed down. So, but this one's not going to be that much more smashed down. It's going to be a little bit, which means it's going to be a little bit further out. Do you see my elbows going out? So the t is going to be wider. When the t gets smashed down, the t goes out further. So I'm going to say it's going to be 2 decimals. I'm going to say that, just a little further out. But this one is really smashed down. I know the z for this. The z is 2.3263, but this is really smashed down. So since it's really smashed down, I'm going to say it's that, because it's really smashed down. Top one's going to be it. So we have to go back to the t-applet, 14 degrees of freedom, 98. So we put in 98. We put in 14 degrees of freedom and 2.63. So we were close. Did I get that one right? Oh, it'd be so crazy if I got that one right. And the bottom one we got right just by trying to figure it out. But you see, we're kind of close. That's how I'm able to guess these, is because I know the z-score, and then I know t's are basically like z's. So when you see something like not looking at, I can see it on screen, obviously. This is a different question, but I know the z-score here is 2.3263, which I just put in before. If you notice, the t is a little further out, but you don't have to memorize these. You're like, I don't want to memorize these. Don't. Go over here to the applet. Put in your degrees of freedom and make your confidence interval. If you notice, I'll zoom out. The confidence interval has the middle portion shaded. So the confidence interval has the middle portion shaded in it. So that's how we can figure it out. We use the applet right there, and we get the answer every time. I love those questions. They're nice and fun. So completely wrong. So let me see the other ones. This one right here is a really great one. We did this earlier. Well, we did this in another class session. But explain what this output means. I am 95% confident the true mean pulse rate for women is contained in the interval blank to blank. That sounds a lot like it right there. Always make sure to practice your interpretation. Try saying it yourself. That way you can get down. I got 46. I'm supposed to round to, so it should be, 46.1. Yeah, it'll accept either. The 0, yeah. If it doesn't, just tell me and I'll fix it. But good job, Elizabeth. Excellent work. What is the margin of error? You should be saying it. Think of your interval. If you go out and to buy a car and you expect it to cost, you're welcome. You expect the car to cost between $10,000 to $14,000. 100-point question. Who knows what the margin of error is? $10,000 to $14,000. What's the margin of error of that interval? People can figure that one out, and then they get stuck on this one. They're like, oh, $10,000 to $14,000 is the margin of error of this. And then I'm like, okay, now do it on this one. They're like, I don't know how to do it. And I'm like, wait, you just did it. You just figured out the margin of error. You just did it. You did something. What did you do? $10,000 to $14,000. What is the margin of error? Everyone usually figures that one out pretty quickly. They're like, don't worry, I know chat's working away. But usually they say $10,000 to $14,000 has a margin of error of this. They're like, okay, that's the margin of error, $2,000. And then let's backwork what you did. Well, you figured out the length of the interval, which is 14,000 minus 10,000. You did that, and then you took half the length. So when you look at this interval right here, it's just a bunch of decimals, so we just type them in. It's ridiculous. My Pearson, you need to not have so many decimals. I act like my Pearsons are enemy. There we go, and then we divide this by 2. There's the margin of error. It's half the length of the interval. And 1 decimal, really? There we go. So that's the margin of error. If they had created a 90%, so now we're going from a 95 to a 90, just do that with your hands, be like 95, 90. So it goes inward. So if we had done this, the interval would be smaller. The margin of error would be smaller. Definitely not today, my Pearson. It would have shocked me if it was today. Let's see, what other questions have we not done? This one right here I think is pretty easy because it's just a put into the formulas problem. I don't think people have problems with that one. This one right here is just it gives you the notation. Here's N, here's S. Oops, that's not S. That's Y bar, and here's S. I think we did that one in the homework help also. This one right here. And so if you have a question, put it in the chat. I'm going to probably stop streaming here in just a little bit because we did some of the hardest ones. A lot of people were stuck on the chocolate chip one because that one gives you the data, which I hadn't done a problem yet where I'd put in a jump, and I was like, I sent people videos, but then I was like, I really should just hop on here and show how to do it. So that way I can explain it, walk through it, and people, because, so one, who's watching? Say hey in the chat if you're watching. Let me see how many people are watching. I can't see it on that screen. I'll just be like, one person's watching. I'll be like, oh no. Hurt my speedrun timer. 2 people watching. Probably one of them's me. But I know you guys are working really hard. And completing the work today is very important. I'm gonna see if there's any other problems that I think people will get stuck on. And I could hop on again later if people are really stuck. We did those, which we hadn't done those yet. Pulse rate, we did that one. Chocolate chip, I think we've done them all. This one right here is another put the prompt numbers into jump. Do we have any? And then this gives you the notation. This is Y bar. This is S. And so then you solve for the interval. Make sure you get your T statistic. Which of the following statements is true about the T distribution of family? As the degrees of freedom increase, the T distribution becomes more normal. Yep. T has fatter tails and narrower center. Yep. He smashes it down. This is the only one that people get confused on is B because it technically has a narrower center. We can observe this. If you want to observe it, do the following. There's the narrower center. And I guess he kind of smashes it down, smashes it. He smashes it. Mr. T smashes it. So there you go right there, the fatter tails and the narrower center. So you can see the center here is a little more narrow. If I start adding a lot of degrees of freedom, you can see it get wider. Once again, narrower center, fatter tails. And that's what they're telling you about it. It's basically the normal. And we got it. Someone just got to check all the boxes. You should understand what it means. Suppose we're making the 95% confidence roll, sample size of 15. What are the degrees of freedom? Boom. N-1. Man, those are nice questions right there. N-1 of the degrees of freedom, sample size -1. And I think if you got a question, say it in the chat. But hopefully this helps people out. I'll probably help out with tomorrow's assignment. And I think I'm moving the one that's on Monday to Tuesday. So make sure to work on tomorrow's assignment on hypothesis testing. Start early on these. That's my biggest advice. Because the earlier you start, the more questions you can ask, the more I can help out. I can help out and do streams. Oh, you're welcome, Elizabeth. I really appreciate you guys working so hard because I know it's a lot. We'll be done with the class Sunday, Monday, Tuesday, Wednesday. We're done. 4 days, less than half a week. 4 days. So you're welcome, Emily. Do you guys have any last questions? I'm still chilling out. I'm still here. If you're stuck on something, jump's not working, there's a question, I'll do another question if you guys want. So I really appreciate you guys being here. And that's like, don't worry. I know people are working, lots of stuff. It's just, I understand. I couldn't imagine being in a class and it's like, okay, wait a minute. I have homework due and I can't get a hold of the teacher. And then tomorrow you're going to have homework due. And if you couldn't get, I was thinking that I was like, I should really go online to help them out. So, cause I was like, it would suck cause there's someone out there who's like, I don't get this. Please, if you don't get this, email me immediately. If you're not getting this, be like, Brian, I don't know what's going on. And I'll try to figure out. I'll try to be like, okay, did you do this? Do you understand this? Please email. But Brian, I'm totally lost. I don't know what confidence roll and testing is. Oh yeah, well, we'll talk about it. Let's do it. But I think that's got it. I need to make more transition screens this weekend. Go back to lecture screen. You work on. So put this right here. I can do the problem this way. I wonder if. No, I have to do it that way. I'm gonna set up something here. I'm gonna try something. Let me try something. Display capture. Okay, add to source. Okay, cool. Yeah, it's not going to work with this sort of layout. It's going to be, it'd be like too small. That'd be, if people are watching this, probably like, it's probably too small. Where's main 2? There's main 2. It would run off the screen if I made it bigger. I could use this in the other screen capture. In the speed run, I could do this. I could add in like a black area up there. I don't know, because it's going to be too small. If I did this, it's off the screen now. I'll have to work on that. Let me remove this out of here. I might, if you have questions, feel free to ask. This is the PowerPoint setup we have. I can also do this offline, but I'm just having fun for a moment. There we go. And then this is where I have to. This is what I do before class every time. I go down here, and then I make it 114. This has been set up to be 114, and then it fits nice and perfect. And then you can't see the illusion that I'm just capturing my screen and able to draw on it in the background. And all the slides are standardized, so I can do this right here. And we're even working on some new backgrounds and stuff. So we're trying to advance this, but coming up with some new cool stuff. Brian just trying things live on stream. You know, I'm going to mess with Streambot for a moment here. I'm going to see if Streambot, which is working right now, but YouTube is just so different on it. Let me look at the Streamlabs stuff. So if anyone comes in, I'm currently just looking at Streamlabs and stuff like that, trying to figure out if we can do extra things. And the only time I can do this is when we're live on YouTube. So I'm just doing weekend how to make custom commands and variables. I think we can do, a lot of people don't know this. Is that? We'll see if that does it. There it is. There's my quote I made back last year. I wonder if people can add quotes. So that's a command people don't know that I figured out a while ago. There's a secret command right there. There's polls. Okay, polls. I wonder if I say vote, if it won't do anything. I just wish there was a list of like every Streamlab. It says I should be able to do this. It's like start a poll. I just like do this. Start what game should I play next? If I can figure this out, this would be so cool because then I can just like write it in the chat. Poll stop. That's how you stop the poll. Minigames duel. Minigame free for all. Minigame boss battle. A bunch of minigame stuff. Events. Song requests. It's weird. Notifications. Mod tools. Users. Find out how to do that. Wait, that's interesting. Settings. What does this do? Sorry if anyone's watching Brian randomly try to figure out how to use Streamlabs Streambot. It only works when you're live on YouTube. Man, there's so many commands. And then let me go back and look. List of commands, Streamlabs bot. Someone's made a list right here. No, maybe not. They're asking for it. Cloudbot. Add customs. It looks like all Twitch stuff. Like it's very much set for Twitch. Very much for Twitch. YouTube stream. I've watched a lot of these tutorial videos. So I want someone to list. Every link is clicked on. Like every link, except for like a few random ones are not. I've clicked on to read about how to do this. And then my questions are not answered. Only at Streamlabs. Cloudbot. It's got all those protections on. Modules. Media share. 8-ball game. Slots game. Duel. Emotes. Have you guys duel each other for points? Commands. So it should be... I made this command a while ago. It might say stat1 has raised their hand. If anyone's watching right now, you can try that. It says that you should be able to raise your hand. And it should be like, stat1 has raised their hand. So, oh, it did it. Took a while. But it only highlights the name because I say it. I wonder if... Let me try this. What is my name? Stats1 UTK. Trying to make some new commands here. Okay. Let me customize this. Reply in chat. Permissions everyone. Confirm. Okay. So now if I try this, let's see if it changed. It might tell me that the cooldown is not over on it. Let me change that. Can I not change that? UCD. User cooldown in seconds. Okay. Whoa, my light's over there. What's that? We'll try it again here. Custom command. Add quote. I wonder if I can add a quote. Let's try this. Add quote. Oh, it worked. Let's see if that works. I don't know if that'll work. open queue, media share, loyalty, top hours, points, remove. See, I should be able to do add points to a user. What does that mean? Let's try it now. Oh. That worked. Let's try this. What is that going to do? It worked. It worked. It worked. Mods. Will it work for someone who's not on stream? Whoa, it worked. Amazing. Figured it out. Is anyone watching right now? If someone is watching, I need your help to try this to see if you can't do it. I might edit out this last whole part of the stream where I'm just like, oh, Jose, what's up, Jose? So I want you to do this right here, Jose. Jose, watch this, Jose. Just for watching, Jose, you're gonna get. I'm just going crazy. You're getting 500 points. I know you've already you got your max points, I think. But watch this. So Jose, you have now gotten. I wonder if it's gonna be mad because I didn't capitalize your first name right there. But we'll see if it does it. If it finds you without the capital, because that's kind of a cool test too. Oh, it said unable to find. So I have to do it exactly how your name's written. So what I want you to do is I want you to take. So yeah, what's interesting? Run your points again because it should. I wonder if you did it before or after it's added right here. So then once you see it says that I've added points to you, which is so weird that it takes like a while right here. Oh, I did it like twice. Oh, I think I might get the command mad at me with that. So let me try this right here. And then yeah, you're probably gonna see your points. Let's see the order. Let's see if it does it. And then once you see the points added, try it again. Oh wait, unable to find. Am I copying your name wrong? That's crazy. Okay, wait. It keeps saying, can you see where it says unable to find? So that's interesting if it's like unable to find this person. It was able to find me and Emily earlier on. You see, that's an issue. I don't know why I would do that. I can edit. I wish I could just do it like that because, but here's what I want you to do. I want you to try using this thing right here because, you know, if I can do it, it's all right, but then it's not finding names for some reason. I want you to try using the exclamation mark, add points, and then put in a name, and then put in, and I have no idea what it wouldn't find you. It worked for Emily. Try doing it and see if it gives you back, like, found the person, did not. You can use your name, my name, anyone's name. Basically, I don't want it to be that students can add points because I need to turn it off if, like, students could also run this. Let students in chat be like, you have 1,000,000 points, and someone gets like 1,000,000 points. I'm like, no, you can't do that. You can't add points to other students. You can't be giving people points like that. You're not allowed to literally create points. Only Brian creates points. So one, we see a problem right here that it's not, you know, I've got you in the loyalty system. Here, right here. I can add the points. I'm gonna add them manually for you, but because I said I'd give you 500, so there's your you're over the 3,000 threshold now. So yeah, let's see what it does. Oh, and then don't use the at. If you see the way I wrote it out, where it's add points, space, name of person, space, amount of points. So I don't think you put an at. Yeah, I think you go like add points, Brian S, and then you put 500. So now it's going to try to add points to Brian S, but it should say unable to find Brian S. We got someone in here named VOOL though, or oh that guy. We're going to use oh that guy. So if we go to I like that right there. We'll see if it responds to you. So I can do oh that guy, and I can say like 50 right here. So we'll see if it. Oh no, haha! You can do it, and we'll see if it finds oh that guy. So I have to turn this off now because students could use it. One, it's not working properly. Two, everyone has permissions on it. So you see, I've successfully added points to oh that guy. So I can't have it that, you know, with the point system, I don't know, like I'd be able to see what's going on. But you do have those powers, Jose. You're the only one who has those powers right now. Start using it quickly. Don't use it. Starts adding millions of points to everybody. Add points, unable to find. Yeah, it looks like it says moderators, which you guys are. You're the mods. And so now, let me go to add points. Oh, that guy, 50. And so we'll see if I still have the powers here. We'll see if Brian still has the powers, but I've removed it from the mods. So if you want to give it another shot, give it another shot, and it should not respond to you anymore because I've turned off that ability for mods. But I don't know if that means I've turned off my ability too, which is kind of a bummer if I don't have that ability. So, which I think is what I did, why I couldn't do it last time. Poll, register your vote, betting, register bet, yeah. Promote your Streamlabs merch store. Game Bowl, 8-ball, slots, dual loyalty store. Okay. Variables. Settings. Okay. And then I think I was going to leave one more thing here while we're streaming right now. Yeah, look, neither of us can add points now, which is kind of a bummer because if I take away that ability from my... Well, and then one, since it wasn't easily able to find the names, then that's like, okay, well, since it couldn't find the names, you know, I can't use it anyways for that purposes, but it's kind of a bummer. Bummer. Polls. Okay, here we go. Let me see if I can make the polls look better now, which is what I wanted to do also. I want to make the polls look really good, which it should be. Nah. I don't know how to make that work. Well, I think that's got it. I think that's got it for right now. We had some fun. We tried to figure some stuff out. That's got it. Good seeing you guys here. I'm going to head off. But that's got it for now. Talk to everybody later. Bye. Email me if you got questions. Bye-bye.